So welcome student with a new topic, curve tracing. Before to start it, you just look over some basic definitions. Let y equal to f of x be the curve and p be any point on it. So first definition here, concave upward means convex downward. If on both sides of point P, portion of the curve lies above the tangent at P, then the curve is called concave upward or convex downward. So you can see here the figure, that curve is above the tangent at P. The point P is called as point of concavity. Similarly, you can define here concave downward means convex upwards. If on both sides of P, portion of the curve lies below the tangent at P, then the curve is called concave downward or convex upward. So here you can see the figure, curve lies below the tangent at P. Point of inflection, the point which separates concave upward and concave downward of the curve is called point of inflection. You can see the figure. Multiple point, if number of branches of the curve passes through a point, then that point is called multiple point. Through multiple point, more than one branches of the curve passes. If n branches of the curve passes through a point, then such point is called a multiple point of nth order. You can see the figure here. Double point, a point through which only two branches of the curve passes, is called double point. Node, yes, now this is a important definition we require. A double point is called node if the branches of the curve pass through are real and the tangents at the point of intersection are real and different. So you can see here the figure. Here the figure is like this, and at this point, so how many branches? So first branch is this one, and again the second branch. So two branches passes through. So this is a double point there. So at this point, if we draw the tangent, so for the first this branch and the second this branch, so tangents are real and distinct, two different tangents at the point P, then that point is known as node. A double point P is called cusp if the tangent at the point of intersection are real and coincide to each other. Means what? A single tangent there at a double point. It means that here the curve, you can see this figure. This is one branch, this is second branch. At this point, here the single tangent to the both branches. So for example like this. So at this point, so first branch, also the second branch, but tangent is a single. So this point is known as cusp. You can see one more figure there like this. Here the common tangent, that is the y-axis is the common tangent. This point is a P. So conjugate point, the point P is called conjugate or isolated point if there are no any real point in its neighborhood. Conjugate point satisfies the equation of curve, but it does not lies on the curve. So for example here, the curve is different, point is there and that point P satisfies equation of curve, but it is not on that particular curve. Singular point, so all these points are known as the singular points. Means what? The point of inflection, node, cusp, isolated point, even though multiple point, double points are called singular points. So in this curve tracing topic, we have to study Cartesian curve, polar curve and parametric curve. So one by one, let's see. So here the Cartesian curve, you know Cartesian means it contains x and y. So there are two different types of Cartesian curve that you know, that is the explicit equation and implicit equation. So explicit curves are y equal to f of x, or you can write x equal to f of y, and implicit curve means what? F of xy equal to 0. So there are some rules. So by using that rules, you can trace any Cartesian curve, maybe explicit or implicit. So which are these rules? So let's see here. Rules to trace Cartesian curve. So there are 5 different rules. First is symmetry, second is origin or point of intersection, third is the region of absence or nature of the curve, fourth is asymptotes, and fifth, that is the tangent or different tangents at different points. So let's start one by one. So first point is the symmetry. Symmetry means what? Mirror image. So in this symmetry there are again 5 points. So we have to check symmetry about standard equations. So means what? So x axis is the standard. Symmetry about x axis, symmetry about y axis, symmetry about the line y equal to x, and symmetry about the line y equal to minus x. So these 4 lines we have to see. It means that symmetry about x axis, symmetry about y axis, symmetry about the line y equal to x, symmetry about the line y equal to minus x, and one more additional thing is there, symmetry in opposite quadrant. So how to check it? So let's see here, symmetry about x axis. If in the given equation all powers of y are even, then the curve is symmetric about x axis. It means that if all powers of y are even, then symmetry about x axis. Similarly, symmetry about y axis, if all powers of x are even, then the curve is symmetric about y axis. So opposite here. If in the given curve all powers of x are even, then symmetry about y axis, and if all powers of y are even, then symmetry about x axis. So you always check first symmetry about x axis as well as symmetry about y axis. If suppose not there, so if suppose the given curve is not symmetric about x axis or y axis, then only you go for the next. Otherwise x and y axis sufficient. Also you note that sometimes maybe all powers of x as well as all powers of y both are even. Then that curve is symmetric about x axis as well as y axis. So very simple way you have to remember there. It means that here the x axis, you have to trace your curve in this portion only. Automatically by mirror image I will get this portion. Similarly, if it is a symmetry about y axis, so I will just trace this part. So automatically I will get this part. Now the third, symmetric about y equal to x line. So very simple. If we interchange y and x and no change in the equation, then it is symmetric about the line y equal to x. So what is there? By interchanging x and y, that is put x equal to y and y equal to x. If the given equation is remain unchanged, then the given curve is symmetric about y equal to x line. Also the fourth one, symmetric about the line y equal to minus x line, means again the same. You replace y by or interchange. So if replace y by minus x and x by minus y. If there is no change in the equation, then that curve is symmetric about the line y equal to minus x. So what is that? By interchanging x and minus y, that is put x equal to minus y and y equal to minus x. If given equation is remain unchanged, then the given curve is symmetric about y equal to minus x line. Now the symmetric in opposite quadrant. So by interchanging x by minus x, so you can see there that you know the x and y axis here. This is the x axis, this is y axis. So by interchanging x by minus x and y by minus y, so I am getting first this x and y interchanging with minus x and minus y. So I am getting opposite quadrant, is it? And that is why here by interchanging x by minus x and y by minus y, if the given equation remain unchanged, then the curve is symmetric in opposite quadrant. So remember there the first point is symmetry. What we have to check? First, symmetry about x axis and y axis. If not there, then only you go for the remaining 3, that is y equal to x line, y equal to minus x line, and opposite quadrant. Second point is origin, or you can extend it as point of intersection. So what is that second point? That is the with x axis, means we have to see point of intersection with x axis. So very simple way, that is put y equal to 0 in the given equation, find the values of x, and we get supposed to be a1 0, b1 0 are the points of intersection with x axis. With y axis means point of intersection with y axis, you put x equal to 0. Note that x axis means what? Y equal to 0. This is the equation of x axis. Similarly, y axis means what? X equal to 0 is the equation of y axis. So put these values there and you find the different values of here y. So supposed to be 0a2, 0b2 are the points of intersection with y axis. It means that the point of intersection with the coordinate axis, we have to substitute x equal to 0, find the different values of y, put y equal to 0, find different values of x. Now the origin means what? 0, 0. So if we put x equal to 0 and it gives y equal to 0, then the curve is passed through the origin, means 0, 0 point. And if it passed through the origin, then only you find the tangent at origin. What is that? Tangent at origin, how to find? That is the lowest degree term equate to 0. Solve that equation and you check degree of each term and you find out the lowest degree terms, maybe 1, 2, 3, whatever there, and that equate to 0. Evaluate that, you find that equation, and that equation gives us the tangent at origin, means it is the equation of tangent at origin. So if curve pass through the origin, then find tangent at origin by using Newton's method. What is that? By equating the lowest degree term, maybe the number of terms, with 0. We get the equation of tangent at origin. This is the point number 2. Now point number 3 is the region of absence, means where curve does not exist. Absent is known as region of absent. Also we have to check nature of curve, means how it varies, how it decreases or increases in the particular interval. So how to check the region of absence? If the given curve is symmetric about x-axis, then express the given equation in the explicit form, that is supposed to be y equal to f of x, and check how y varies as x varies. If y square is less than 0, means y square is negative, then definitely y equal to under root of negative means imaginary. For some value of x, maybe x is greater than a, then curve does not exist for these values. It means that very simple way you can remember, that is you find where y square becomes negative, means y becomes imaginary. Y becomes imaginary for what values of x? So for that values of x, curve does not exist because y is imaginary, means not exist. Similarly, if suppose curve is symmetric about y axis, then express the given equation in the form of x equal to f of y and try to find out where x square becomes negative, means x becomes imaginary and curve does not exist for these values. Along with this, also you observe by the given equation how x varies or y varies as x or y changes there. Now the fourth point is asymptote, very important point there, that is the asymptote. So asymptote means the tangent to the curve at infinity, means our curve. What is meant by tangent? Tangent means that curve and that tangent line meet to each other at a single point. For example, here this is a curve and at this point we are saying tangent. It means that this line is a tangent at this curve at this point. It means that this tangent and this curve meet to each other at a single point P. Here asymptote. Asymptote means what? Tangent to the curve at infinity. It means that our curve and that asymptote meet to each other at infinity, means not for a finite value. So it means that if this line is asymptote and here is our curve, so this line means this tangent and our curve meet to each other at infinity. But that process will start like this. So whenever there, so it will be like this. It will not touch. They will meet at infinity, but the curve is like this. Similarly, if supposed to be, I am getting this line is a asymptote. So definitely whatever our curve, all possible things are what? So this our curve will meet to this line like this and like this, but see there that tangent means that asymptote will not meet to our curve at finite value, is it? But that process will start maybe like this, all possible. So that depends on the remaining points, so where it exists, maybe this one, this one, this one, this one, or maybe any two, or maybe all, is it? But these are the possible. If asymptote is there, that asymptote and our curve will try to meet each other. So like this is a asymptote and this is our curve, so they will try to meet like this. So here this is a line and this is our curve, so it will just try to meet to this line, maybe in this direction, maybe in this direction, that depends on the remaining points. Okay, so note that asymptote means what? It is a tangent at infinity. A curve of degree n have maximum n asymptotes. It means that if degree is 3, then there will be 0 asymptotes, maybe 1 asymptote, maybe 2 asymptote or 3 asymptotes, but not more than that. So maximum n asymptotes. So here one by one we will see. So here first is asymptote parallel to x-axis. How to find asymptote parallel to x-axis? By equating the coefficient of highest power of x to 0. We get the equation of asymptote parallel to x-axis. It means that you solve that equation and you find out highest power in x and the coefficient of that highest power in x equate to 0 gives us asymptote parallel to x-axis. Similarly, asymptote parallel to axis, by equating the coefficient of highest power of y to 0, we get equation of asymptote parallel to axis. And oblique asymptote, oblique means any other line which is not parallel to x-axis or y-axis. So to find oblique asymptote, put y equal to mx plus c, means it is the equation of line in the given equation, and then equate the coefficients of two highest powers of x to 0. We get values of m and c. It means that when we put y equal to mx plus c in the given equation, we will get here in equation in x. So in that equation you find two highest powers of x and then coefficient of these two highest powers of x equate to 0. So by these two equations I will get values of m as well as constant c. So put here y equal to mx plus c, and this is new equation, equation of line, which is nothing but your oblique asymptote. So this is very important point there, asymptote. And now the fifth point is the tangents. So special point, you can say that tangents, but other than origin. Why? Because we already found tangent at origin if exists. So note here, if dy by dx equal to 0 at some point AB, it means that we have to find dy by dx, means given equation of curve you differentiate with respect to x, then you find dy by dx at particular point, in some point AB, and if dy by dx equal to 0 at some point, then tangent to the curve at that point is parallel to x-axis and dy by dx equal to infinity, then the tangent to the curve at that point is parallel to axis. So note these two important points there, 1 and 2. And additional, if you want, you can check here dy by dx is greater than 0 in the interval, any interval AB, then the curve is strictly increasing in that interval AB, and if dy by dx is less than 0 in the interval AB, then the curve is strictly decreasing in the interval AB. So remember these two also. But important points are first two, that is dy by dx equal to 0 at some point AB, then tangent at point AB is parallel to x-axis, and if dy by dx equal to infinity at some point AB, then tangent at point AB is parallel to y-axis. Also you note that the curve attains its maximum or minimum value at the points where dy by dx equal to 0. And note that always find dy by dx at points of intersection with coordinate axis and the line of symmetry. It means that this point we have to check at which points, if we get the point of intersection with coordinate axis and a line of symmetry. If supposed to be there is only one point of intersection with x or y axis, which is nothing but origin, then need not to find this tangent. If under the point, that is the points of intersection, if we get number of points other than origin or any point other than origin, then only you find here the tangents at a different point or that point. So note this is very important note here, always find dy by dx at points of intersection with coordinate axis and line of symmetry, if any. Means if supposed to be line of symmetry is different, y equal to x or y equal to minus x, then the point of intersection with that line, there you find dy by dx. So these are the 5 points we have to remember. First is symmetry, second is the origin and point of intersection, third is the region of absence and the nature of curve, fourth is the asymptotes, and the fifth is tangents. So by using these 5 points, definitely we can trace the any Cartesian curve. So consider example on curve tracing in Cartesian form. Example, trace the curve xy square equal to 4a square into a minus x. So how to trace this curve? So there are 5 points. Don't forget these 5 points. First is symmetry. Second is the points of intersection and origin. Third is region of absence. Fourth is asymptote, and fifth is the tangent. So one by one you write the theory part and then you think about the curve. So solution, given equation of the curve is xy square equal to 4a square into a minus x. Here first point is symmetry. So there are 5 points in the symmetry. Symmetry about x-axis, symmetry about y-axis, symmetry about y equal to x line, symmetry about y equal to minus x line, and symmetry in opposite quadrant. So first you check symmetry about coordinate axis. If not, then only you check for third, fourth and fifth. So here all powers of x are not even. You can see here power of x is 1. Now all powers of y, so here only one y, and that is the y square. So all powers of y are even. Therefore curve is symmetric about x-axis. Second point is points of intersection and origin. So how to find points of intersection? Put x equal to 0, find all values of y. So what this implies? So you can observe here, if we put x equal to 0 here, so I am not getting any value of y, and that is why it is necessary to write the same curve as y square equal to 4a square into a minus x upon x. And now you substitute x equal to 0. If we put here x equal to 0, so anything by 0 I am getting infinity. So this implies y equal to infinity. So here supposed to be 0 and infinity. Now put y equal to 0. What this implies? So x equal to, if we put here y equal to 0, so I am getting this x, this side. So it is 0 and this is equal to 0. It means that here a minus x equal to 0. So here I am getting a minus x equal to 0 implies x equal to a, and therefore which point is there? That is a comma 0. So if we substitute here x equal to 0, I am not getting 0 0. Even though if we put y equal to 0, I am not getting 0 0. It means that curve does not pass through origin. So for origin, you write there curve does not pass through origin. Therefore, need not to find tangent at origin. Now third point is region of absence. So how to find region of absence? This is the first example. So carefully you see, if curve is symmetric about x-axis, then you find y equal to f of x, or write the equation y equal to f of x form. And if it is symmetric about y-axis, then you write x equal to f of y. So here equation I can write y square equal to 4a square into a minus x upon x. Now you find values of x such that this y square becomes negative. So when this y square becomes negative, so left hand side is negative when right hand side is negative. And in right hand side, how many terms that decides the sign of right hand side? So here 4a square, it is a constant. So a minus x and x. So there are two terms, a minus x and x. So by these two terms we have to decide the right hand side is negative or not. And if right hand side is negative, means definitely left hand side means y square becomes negative. So here a minus x is less than 0 means what? It is a negative. Less than 0 means it is a negative. And when a minus x is less than 0, so it means that when a is less than x, so you consider this minus x, this side it will be plus. Just like a equation you solve inequalities. So I am getting a is less than x. What is the meaning of this? It is the x is greater than a. And by the second term, that is the x term, here x itself less than 0. It means that x negative. This becomes negative. When x is greater than a, this term becomes negative. So you can roughly check here, what is x equal to a? This is x equal to a, and beyond this, x is greater than a, this region, and x is less than 0 means this region, because here this is the y-axis means this is the origin, and here. So our curve is exist in between these two parts, means these two lines, here y-axis and this is x equal to a line. So in between these two lines curve exists. So here I will write, if x is less than 0 and x is greater than a, y square becomes negative. Y square becomes negative means, what is the y? It is the under root of negative. It means that it is a imaginary. Therefore, y becomes imaginary. And for imaginary values, curve does not exist. And therefore, curve does not exist for x is less than 0 and x is greater than a. Now, which is the fourth point? Asymptotes. Asymptotes means tangent at infinity. So first point in that, parallel to x-axis, means asymptote parallel to x-axis. So how to find asymptote parallel to x-axis? Coefficient of highest power in x equate to 0. So first of all, highest power in x. So solve this equation. Given equation is what? So xy square equal to 4a square into a minus x. So solve this one. This implies xy square minus 4a cube plus 4a square x equal to 0. Here power of x is 1. Here power of x is 0. Here power of x is 1. So there are two terms having power of x is 1 and it is the highest power in x. So find here coefficient of highest power in x. How? So common out x. So I am getting here y square plus 4a square into x minus 4a cube equal to 0. So how to find asymptote parallel to x-axis? Coefficient of highest power in x. So what is it? It is a y square plus 4a square equate to 0. And if I am getting valid equation, then it is the equation of asymptote. If invalid answer, then asymptote does not exist. So let's see here what happened. So y square equal to minus 4a square. So note that here y square becomes negative. It means that asymptote does not exist because y is imaginary. So here asymptote parallel to x-axis does not exist. Now what about parallel to y-axis? Again the same, that is the coefficient of highest power in y equate to 0. So here the equation we already solved. So here, so highest power in y. So here y square. And what is the coefficient of y square? It is a x. So here x equal to 0. And it is a valid because x equal to 0, it is the equation of y-axis. So x equal to 0 is asymptote. Now in that asymptote, third point is oblique asymptote. But note that where we have to find oblique asymptote, if in the equation power of x as well as power of y is greater than or equal to 3. Note that it again, that is the power of x as well as the power of y in the given equation of curve is greater than or equal to 3, means both. Then only you find oblique asymptote, otherwise not. Now what is the fifth point here? Tangents. So where to find tangent? So we have to find tangent at points of intersection with coordinate axis or line of symmetry. So here coordinate axis here. So points, which are the points? 0, infinity. So okay. So here a comma 0. So here points of intersection 0, infinity and a0. So this is a valid a0. So we have to find tangent at point a0. So find dy by dx. So what is the equation? Xy square equal to 4a square into a minus x. So differentiate with respect to x. So we'll get first constant, derivative of second, plus second constant, derivative of first, means here u into v rule, equal to 4a square constant and derivative of a minus x is minus 1. Now what about dy by dx? So you find dy by dx. So I am getting here dy by dx equal to minus 4a square minus y square upon 2xy. So at points of intersection with coordinate axis, there only you find dy by dx. So here that point is a comma 0. So at a comma 0, you find dy by dx. So I am getting dy by dx equal to minus 4a square, y is 0, so minus 0 upon, due to this. So I am getting here infinity. Note that if I am getting here 0 by 0, then don't consider this point or this particular dy by dx. So here I am getting dy by dx equal to infinity, and we know dy by dx equal to infinity at some point, then tangent to the curve at that point is parallel to y-axis. Therefore, tangent to the curve at point A0 is parallel to y-axis. And now this theoretical part is finished. Now actual curve. So when we are going to trace the actual curve, you just consider a plane x and y axis there. So here I am taking x axis as well as y axis. After that, line of symmetry. So curve is symmetric about x axis, means whatever the curve above x axis, same curve is below x axis. So first point symmetry, and also I will consider here the region of absence, means where actually curve exists. So you can see here x is less than 0. So here by this figure I am getting, so here this is x axis, it is a y axis, here origin, and curve does not exist less than 0, means here curve does not exist, and also curve does not exist beyond x equal to a. Suppose this is x equal to a, so here curve does not exist, so you consider the value. So this is x equal to a, so curve exists in between these two, x equal to 0 and x equal to a. So this point is a comma 0. So when we are going to trace the curve, you write theoretical part first, decide the theoretical part first. After that, you see the line of symmetry and region of absence. After that, curve pass through which points? One by one points here. So symmetry over points of intersection. Curve pass through 0 and infinity. Okay. So infinity I can't show. Second is a comma 0. So a comma 0, this point, and at that point, means at a0, which is a tangent. So tangent is parallel to axis. First of all, you should know that is tangent means if any line is tangent to the curve, it means that that line touches to the curve at a single point. For example, this is a tangent at this point. So definitely nature of the curve is this one or this one or both, means that curve touches to that line at a single point. Is it? Suppose this is a tangent at this point. So nature of the curve is like this. So definitely like this. Maybe one or both. Okay, that depends on the remaining. That is the region of integration where curve exists, where not, like that. So here at A0 tangent parallel to y-axis. So this is the y-axis. This is your y-axis. So parallel to y-axis means this x equal to a line. This line is parallel to y-axis. So this line is the tangent at which point? A0. So at A0 I am getting nature of the curve is this one or both. But definitely this is not there. Why? Because curve does not exist beyond x is equal to a, means x is greater than a. Okay, so here I got nature of the curve. After that, what is the next point? So at A0 I got it. Second, origin curve does not pass through origin, region of option we already considered. Now asymptote parallel to x axis does not exist. Parallel to axis means x equal to 0 is asymptote. So very important point here, asymptote. We already discussed in the theory part. Suppose this is asymptote. So asymptote means our curve and this asymptote meet to each other at infinity. So that is why now our curve will be try to meet this one like this. Maybe both or single. But it will not touch here because both will touch to each other at infinity. And therefore x equal to 0. X equal to 0 means here y-axis is the asymptote. So definitely nature of the curve is this one or this one at this point. Because both that our curve will meet to each other at infinity, and that is why we got this point 0 comma infinity. So by remaining points I will try to find where curve does not exist. So definitely here curve does not exist. Why? Because in this region curve does not exist less than 0. So only one. So this curve and this curve you try to join, but smooth curve. It's not supposed to be point like this. Smoothly you join. So how we get? So I am getting here nature of the curve is like this. Try to maintain symmetry about x-axis here. They will check here only the tangents point, asymptotes points, this point. It means that this line is a tangent. So nature of the curve is never be like this. It should not be like this. It should be smooth like this. This is asymptotes, means nature of the curve is like this. Right? And here try to maintain symmetry. But it is not a drawing class, means no one will check correct this distance and this distance or what. But roughly it should be same. So this is your required curve. So here you can write, if you want, this line is what? Tangent. At which point? At a comma 0. This is a asymptote. So y-axis is asymptote here. And here definitely symmetry. Right? So this is your curve. So you can consider this also. The same curve I can consider this one. See there. This is the tangent, asymptote and this one. Right? So next example. Trace the curve ay square equal to x square into a minus x. So solution. Given equation of curve is ay square equal to x square into a minus x. Means same thing I can write as y square equal to x square into a minus x upon a. So first point is symmetry. So write here theory part. So all powers of x are not even. Now second point, all powers of y. So here all powers of y are even. So therefore symmetry about x axis. Right? So first always check symmetry about x axis, symmetry about y axis. All powers of x are not even because x power 1. So not even. So therefore, the second point is symmetry about x-axis. So all powers of y are even and therefore it is symmetry about x-axis means opposite. Second point, points of intersection and origin. So here at the same time you find origin also. So how to find? Put x equal to 0, find all values of y, put y equal to 0, find all values of x. If we get 0, 0, then that curve passing through origin. If it curve passing through origin, then find tangent at origin. How? Lowest degree term equate to 0. So without fail we should have theoretical part. So one by one, put x equal to 0, find all values of y. So I am getting here y equal to 0. If we put x equal to 0, so directly I am getting y equal to 0. So definitely here 0, 0 means curve pass through origin. Second, put y equal to 0. What this implies? If we put y equal to 0 means here y equal to 0, I am getting this is equal to 0. And therefore, x equal to 0 and a minus x equal to 0. And this implies x equal to 0 and x equal to a. And it gives us 2 points. One is 0, 0 and second is a 0. So finally, I am getting here. So points, one is origin and second is a comma 0. So if it pass through origin, so here you write about the origin, curve pass through origin. How? Because we got there 0, 0 point. Now tangent at origin. How to find tangent at origin? Lowest degree term equate to 0. What is the equation? Ay square equal to x square into a minus x. So write in the form of f of xy equal to 0. So I am getting ay square minus ax square plus x cube equal to 0. So lowest degree term. What is degree of this term? 2. What is degree of this term? 2. What is degree of this term? 3. So lowest is 2, 2. So there are two terms equate to 0. Lowest degree terms ay square minus ax square and both equate to 0. So I am getting here y square equal to x square and this implies that y equal to plus minus x are tangents. Means here two tangents at origin. Next, region of absence, third point. So how to find? Here symmetry about x-axis, therefore you write y square equal to or y equal to f of x. So y square equal to x square into a minus x upon a. So when y square becomes negative, left hand side becomes negative, when right hand side negative. A is always positive, you consider, right? It's a constant term. So there are two terms which contains variable means x. So here x square and a minus x. So x square and a minus x. When this becomes negative, so x square always positive. Only we have to decide when this becomes negative. So only one term will decide the sign of this side, means sign of y square. So when a minus x is less than 0 means negative. When a is less than x implies x is greater than a, then this becomes negative. And when this becomes negative means y square becomes negative. And that is why I can write here, if x is greater than a, y square becomes negative and therefore y becomes imaginary. Under root of negative, imaginary. Imaginary means curve does not exist. So therefore curve does not exist. X is greater than a. It means that if we consider this is a x-axis, this is y-axis and this line is x equal to a. So beyond this curve does not exist. Means here this part up to infinity curve exists. Now fourth point, asymptotes. So first is that parallel to x-axis. So how to find parallel to x-axis? Means asymptote parallel to x-axis. So coefficient of highest power in x equate to 0. So we already have the equation here, this one. This is our solved equation, right? Means f of xy equal to 0. Or here also you can solve it again. if you want. That is a ay square equal to x square into a minus x. This implies that ay square minus ax square plus x cube equal to 0. So what is the highest power in x? So here power of x is 0, here 2 and here 3. So highest power is here. What is the coefficient of x cube? It is a 1. So 1 equal to 0. It is not valid. It is not valid answer or valid equation. And that is why asymptote parallel to x-axis does not exist. Now what about parallel to y-axis? Means asymptotes parallel to y-axis, highest power in y you find, and then coefficient of highest power in y equate to 0. So what is highest power in y? Here 2, here 0, here 0, powers of y. So 2, it's the highest. What is the coefficient? A. So a is always positive, means greater than 0, never 0. So it is also not valid answer, a equal to 0, and therefore asymptote parallel to y-axis also does not exist. Is it necessary to find oblique asymptotes? When we have to find oblique asymptotes, powers of x as well as powers of y greater than or equal to 3, then only we have to decide whether we have to find oblique asymptotes or not. So here not, because even though power of x is 3, but power of y is not equal to 3 or greater than 3. In the fourth point, asymptotes does not exist. Now the fifth point is a tangent. So you check whether it is necessary to find tangents or not. If points of intersection with coordinate axis, then only. So here points of intersection except origin, because for origin tangent is a special point. So in the fifth point, tangent, where we have to find tangents, points of intersection with coordinate axis, but not origin, because for the origin separate points tangent at origin. So here point is A0. So here we want to find tangents. You consider again equation of curve ay square equal to x square into a minus x. Differentiate with respect to x. So I am getting here a constant derivative of y square is 2y dy by dx equal to x square constant derivative of a minus x is minus 1 plus derivative of x square is 2x and a minus x is constant, and that is why I am getting dy by dx equal to minus x square plus 2ax minus 2x square upon 2ay. Simplify this. So I am getting dy by dx equal to minus 3x square plus 2ax upon 2ay. So at which point we want to find dy by dx? At a comma 0. So at a comma 0 dy by dx. So put here x equal to a and y equal to 0. So I am getting here minus 3a square plus 2a into a. So 2a square. Numerator is not 0 but denominator is 0, and that is why infinity. And we know if dy by dx equal to infinity means tangents parallel to y-axis. Tangent at point A0 parallel to y-axis. Now actual curve. So theory part is finished here. So consider the curve x-axis, y-axis and any point or line which getting from these points. So x-axis, y-axis, this is x-axis, this is a y-axis, this is x-axis, this is y-axis, and one point. So where curve does not exist, you consider here, that is the symmetry about x-axis. So above x-axis we have to draw or trace the curve. Then region of absence, here x is greater than a, so you consider the boundary x equal to a line. Supposed to be this is x equal to a line, means this point is a comma 0. Curve does not exist beyond this. It means that curve exists from a0 point to minus infinity. So first of all, that is symmetry, then region of absence we got, then points of. So first point is over, second point is over, Okay, second point here 0, 0. Curve pass through origin. Okay, curve pass through origin and curve pass through A0. So we have now these 2 points. So curve pass through this point also 0, 0 and curve pass through this point also. At 0, 0 tangents are here y equal to plus x, y equal to minus x. Two tangents are there. You know that which is line y equal to x and this is y equal to minus x. So curve pass through origin and at origin y equal to x and y equal to minus x. Both the tangents. So note that if this line is the tangent at this point, so nature of the curve is this one or this one or both. That depends on the remaining points. So here y equal to x is a tangent. So definitely nature of the curve is this one or this one. Y equal to minus x means nature of the curve is at that point this one or this one. Now second is that curve passing through the point a comma 0. It means that this is the only possibility. And at that point which is a tangent? Tangent parallel to y-axis. Means this is a y-axis and tangent parallel to y-axis is this line. It means that at this point this line is a tangent, so nature of the curve is like this. And therefore by this all theory I have the curve is like this. Here this one. Due to symmetry I am getting like this. Try to maintain symmetry here and it's continue like, because this beyond this it's up to infinity. Try to maintain symmetry there. It's up to infinity. This one. So this is the nature of curve. Note that you can write this is a tangent at point A0. This y equal to x, it is a tangent at origin. This is your required curve. So same curve is this one. Okay, here the tangents, this tangents at origin, tangent at point A0. This is a node. We know that is a double point is said to be node if tangent at that point are different, real and different, distinct. So here is your final curve.